Alright, hello grade 10s. I hope you're well. As you guys are setting in to prepare for your grade 10 exam or grade 10 course, I thought I should actually come in and do a few exam type questions. Hopefully these will be helpful and you guys can be able to read extremely well if you haven't written yet. But if you have written already, then I guess this will be good revision. Okay, here's the first question. Given k is an element of 0, 1, 2, and negative 4. So these are specific values of k that are listed. The question is, for which values of k will the square root of 16 over 1 minus k be 1 rational? So what we want to do is we want to check the substitution of 0 into this square root. So if we take 0 and in the place of k, since k is an element of these numbers, and these are the only numbers that we are given, if we take 0 and we substitute it here, it's 1 minus, in the place of k, we'll have 0, 1 minus 0. 1 minus 0 is 1 in the denominator. 16 over 1 is 16 in the square root. The square root of 16 gives you 4. And 4 is basically 4 over 1 written as a number that is rational. So as I said, if we take that 16 and we substitute 0, we get 16 over 1, which is the square root of 16, which is 4, and 4 can be written as 4 over 1, and this 4 over 1 is rational. So if we substitute 0 in this square root, we get a 4 over 1, which is a rational number. So substituting 0 gives us a rational number. Okay, let's substitute 1. Substituting 1, okay, 1 minus the 1 here, okay, 1 minus 1. Substituting 1 in the place of k gives us 0 in the denominator. Okay, so in other words, if I substitute a 1 in the place of k, I get 1 minus 1, which is 16 over 0. Now we know that a division of a number by 0 gives us what? Something that is undefined, right? Division by 0 gives us something that is undefined. Okay, so we know that substituting 1 is undefined. And if we substitute 2 into the expression, 16 over 1 minus 2. Okay, remember substituting 2 is just substituting a 2 that is positive, but there's a negative sign before the substitution of k, which is 2. 1 minus 2, that gives you 16 over negative 1, which gives us negative 16, because a positive divided by negative is negative. 16 divided by 1 is 16, so that's a negative number underneath the square root. A negative number underneath the square root, guys, we know is non-real. That's a non-real situation. Okay, and guys, a non-real situation is different from an undefined situation. These do not mean the same thing. Okay, then lastly, substituting negative 4 in the place of k. If we substitute negative 4, 1, there's a minus sign already in the denominator. In the place of k, we substitute a negative 4. What's 1 minus 4? That is 16. 1 plus 4, because a negative times a negative is positive. The square root of 16 over 5. This obviously will give me 4, if I apply the square root at the top, over root 5. And guys, 4 over root 5, this is definitely going to be an irrational number. Okay, So what value of k when substituted will give me a rational number? I saw that it's only when I substitute k that is 0 that I get a rational number. So when k is equal to 0, I get a rational number. Which value of k will lead me to an irrational number? It's when I substitute -4. K is equal to -4, I get an irrational number. Which value of k gives me an undefined number? It's when I substitute k as 1 that I get an undefined number. So k is equal to 1. And that will have been me having completely answered the question that given k is an element of 0, 1, 2, -4, for which values of k will the square root of 16 over 1 minus k be rational? It's when k is equal to 0. That's when I get a rational number out of this. Irrational, it's when k is equal to -4, right? Because I get a value which basically shows that that is a number that cannot be written in the form of a fraction where the numerator and the denominator are integers and where the denominator cannot be 0. And basically the expression of that number shows a non-recurring and non-terminating decimal. It's when k is equal to 1 that I get a undefined number, because I know when the denominator is 0, that means undefined. But substituting 2 does not lead to an undefined number, it leads to a non-real number, because when there is a negative inside the radical or the square root or an even root, we know that when there's a negative number inside the even root, that's when we get non-real. So k is equal to 2. If there was an option to write down when do I get a non-real number, when I substitute k, that's when I would say k is equal to 2. Okay, so non-real and undefined do not mean the same thing. Undefined is division by 0. Non-real is a negative number inside the square root or any even root that houses a negative number. That is non-real. Okay, let's move on to the next question. Write 0.68 with the dot on top. What does the dot on top of the numbers mean? Do we know what the dot on top of each number means? That means the decimals or the numbers after the comma are repeating. They are recurring decimals. So I need to write this recurring decimal as a common fraction. How do we do that effectively? So guys, we let x be equal to 0.686868. We know that 68 is repeating. Then we move the decimal until we can actually get the repeating 68 still on this side. 686868 dot dot dot. Equation 1, equation 2. That means what do we multiply the left hand side, on the right hand side with to get 68 to repeat again? So if we move the decimal 1 2 times, that will give us 68, 686868. But moving the decimal 1 2 times means I've multiplied this x by 100. The zeros indicate how many times I moved to the 1 2 times to the right. So I multiply what is there, 1x, by 100. So that then allows me to move the decimals 1 2 times. So then I have 100x is equal to 68,6868, because 68 repeats infinitely. It repeats forever in that direction. That's my equation 2. Then I'm going to say equation 2 minus equation 1. Equation 2 minus equation 1 means 68 minus 0 here on the left. 68 minus 0 is 68 on the right. Okay, this 6 minus 6 gives me 0. 8 minus 8 gives me 0. So basically all the decimal numbers, they fall away to give me 0, which means I can just simply write that 68, 686868 minus 0, 68666868 gives me 68 on the left hand side. I'm on the right hand side. Then 100x minus x. What's 100x minus x? That is 99x. So that's what I mean by equation 2 is equation minus equation 1. 100x minus x gives me 99x on the left. 68, 6868 minus 0, 686868 gives me 68. Then I divide both sides by the coefficient of x, which is 99. What I do on the left, I do on the right. And I get an answer of x is equal to 68 over 99. And the question is, can this fraction simplify any further? 5 seconds, 30 seconds. You guys let me know in the comment section, can this fraction be simplified any further? I don't know if the video is still blurry. I would hope not. Okay, seems like the video is probably better. We cannot simplify this any further. This is basically the rational fraction, and that is how we write a recurring decimal to a fraction by calculation, step by step. Okay. The objective of this is to form two equations whereby after the comma the numbers are the same. Okay. Yeah, I don't know why it's blurry, guys. I have no idea. And I don't understand why it's blurry from your side. I really don't know. Why it's blurry, I don't know. I don't know, guys, why. Is it still blurry? I don't know. I don't know, guys. I don't know. Next question. Between which two consecutive integers is the cube root of 50? Which two integers does cube root of 50 lie? Okay, so what you must note here is that this is a cube root. So since it's a cube root, it means I need to find, because it's a cube root, I need to think of perfect cubes that are consecutive, that lie on the left and on the right. So here's the cube root of 50. With the inequality signs written as less than on both left and right. This greater than whatever, same thing, less than something. You must think of perfect cubes that lie on the right and on the left of this cube root. So the perfect cubes, remember, perfect cubes are numbers that are formed by multiplying a particular natural number twice by itself. Okay, 1 times 1 times 1 is 1, that's a perfect cube. 2 times 2 times 2 is 8, that's a perfect cube. 3 times 3 times 3 is 27, that's a perfect cube. 4 times 4 times 4 is 64, that's a perfect cube. So think about it. 50 is followed by 64. So if we have 64 this side, 27 is before 64 as a perfect cube. 27, we can put the cube roots of both cube root of 27 and the cube root of 64. What's the cube root of 27? It is 3. What's the cube root of 64? It is 4. So it means the cube root of 50 lies between 3 and 4 in that order. So that's something to note. If we are dealing with cube roots, then you must think of perfect cube numbers. If this was a square root, we would think of perfect square numbers. Remember, perfect square, unlike a perfect cube, is multiplied by itself to form it's a number that is it's a number that is formed by multiplying by itself to get a perfect square number. That's a perfect square number. Okay, a natural number that's multiplied by itself is what forms a perfect square number. But here we were thinking of perfect cube. So 3 and 4 are the perfect cube numbers. Okay, 27 and 64 are the perfect cube numbers that lie on the left and then on the right of cube root of 50. Aluwani Mbenzi, hello, how are you doing? Okay, so please guys, that's how we find the numbers that are integers that lie on the left and then the right of the cube root of 50. Okay, we think of perfect cubes. Since it's the cube root of 50, we think of perfect cubes that lie on the left and on the right of 50. We know that it is 27 and 64. Then we just simply put the cube root of both perfect cubes. The cube root of 27 is 3. The cube root of 64 is 4. Therefore, in between is what? Cube root of 50. And it is 3 and 4. That basically are the integer values that are consecutive, where the cube root of 50 lies. Okay, and as simple as that, answering that question. Okay, move on. Okay, then we move to simplification questions. 3x minus 1 over 4, the whole thing squared. Guys, whenever there's a minus sign or a plus sign in between two terms inside a bracket and there's an exponent, that is an invitation to open the number of brackets that exponent says. Then we are now going to apply FOIL. 3x times 3x, positive times positive, 3 times 3 is 9, x times x, we multiply same variables, we keep the base, we add the exponents. We know there's a 1 and a 1, that gives us x squared. Then we say 9x times negative 1 over 4. In the numerator, 3 and 1, positive times a negative is negative. 3 and times 1 in the numerator is 3. Then in the denominator of 3, we have a 1 that we don't see. 1 times 4 gives us 4. And then the x, you just simply put that x next to the numerator, which is 3. But you can put it in line with the division line that you see of the fraction. That basically is correct. You can't put this x in the denominator. It's an x that is in the numerator. Then we take negative 1, we multiply with 3x. Negative times positive is a negative. Same thing. 3 times 1 at the top is 3 over 4 with the x next door. And negative 1 times negative 1 over 4 times negative 1 over 4. Negative times a negative is positive. 1 over 4 times 1 over 4. 1 times 1 at the top is 1. 4 times 4 is 16. Then you add the like terms that are in the middle. So you have 9x squared minus. Now, when the denominators are the same with fractions, you keep the denominator. Okay. The x obviously is in the numerator, but you can put it in line with the division sign. Negative 3 minus 3 is negative 6. Okay, negative 6 over 4 plus 1 over 16. But of course, the middle num can be simplified to become negative 3 over 2x plus 1 over 16. Now, some people will insist on actually making sure that Since you have a denominator that is 16 and the lowest common denominator is 16, you can then go ahead and form equivalent fractions of 9 that equivalent fractions of the denominator that is 16. So then the question is, if you want to form a fraction with 9x squared, or in the denominator you have 1 times what is 16, it is 16. So that means you multiply by 16 at the top as well. That's 9 times 16, that gives you 144. So you have 144x squared minus 2 times what gives you 16, it is 8. So if you multiply by 8 at the bottom to get 16, what do you multiply at the top? You multiply by 8. Negative 3 times 8 is going to give us 24. And then if you want to form 16, this is already 16. So that means in the numerator you multiply by 1. Since you multiply by 1 at the bottom, you multiply by 1 at the top, you get this 144x squared minus 24x plus 1 all over 16. If you want to write this as one term with a LCD of 16, these are all equivalent fractions of what you had in the expression initially. So that's basically how you could finish it off if you desired. But I think there would be no problem if you left the terms, 3 of them, but as long as the answer is simplified, if you leave it like this. But I think in some textbooks they do actually go the extra mile and write the answer with a LCD of the terms that you have if it is in fraction form. Let's move on to this. Okay, 3 marks in the back. Okay, you have a binomial, 2 terms inside the bracket with a trinomial. So what do we do here? Here it's simple, it's straightforward what we do. 2x squared times 4x, 2x squared we multiply by 6x squared y, 2x squared we multiply by 9x squared y squared. And when we do so, when we multiply out, we remember to multiply the sign, the number, and the letter. Positive times positive, positive. 2 times 4, 8. X squared times x to the power 4, the bases are the same. When you're multiplying x squared and x to the power 4, you keep the base, you add the exponent. 2 plus 4 is 6. 2x squared times 6x squared y. Positive times a positive, positive. Sign, number, 2 times 6, 12. Letter, x squared times x squared, x to the power 4, then the y, you put it next door nicely. You take the 2x squared, you multiply by 9x squared y squared. 2 times positive times a positive, positive, that's the sign. Number, 2 number times 9 is 18. Letter, x squared times x squared, you keep the base, you add the exponents. 2 plus 2 is 4. Then the y squared, guys, next door. We are done distributing 2x squared to all 3 terms. You got these 3 terms. Now you take the negative 3xy, you do the same thing. You multiply it with all 3 terms. Negative times a positive, negative. Number, 3 times 4, 12. Letter, x times x to the power 4, x to the power, what's 1 plus 4? It is 5. Then the y, you put it next door to the variable x to the power 5. We're done. Negative 3xy, you multiply it with 6x squared y. Negative times a positive, negative. 3 times 6, that's 18. X to the power 1 times x to the power 2, x to the power 3. Then y times y is y squared. Because 1 plus 1 is 2. So no, go. You have that exponent here, you have that exponent there. 1 plus 1 is 2. Then lastly, you take negative 3xy, you multiply by 9x squared y squared. Negative times a positive, negative. 3 times 9, 27. X times x squared, remember you keep the base with the variables that are the same. You add the exponents. 1 plus 2 is 3, so you have x to the power 3. Then the last y, y to the power 1 times y to the power 2. The bases are the same. You keep the base y, you add the exponents. 1 plus 2, that's y to the power 3. Once you are done with the distribution, remember, if you took 2x squared, you distribute it to 3 terms, you should lead to 1, 2, 3 terms. You take negative 3xy, you distribute it to 1, 2, 3 terms, you should get an additional 1, 2, 3 terms. So in total, you should want to have 1, 2, 3, 4, 5, 6 terms, which is what you have really indeed. You've removed the brackets by multiplying and distributing, considering the sign, the number, and the letter. Now you are going to look for like terms. 8x to the power 6 does not have a like term because like terms are terms that have the same letter with the same exponent in that term. No friends. 12x to the power 4y, does it have a friend? Look at, this is x to the power 4y, this is x to the power 4y squared. They nearly look like friends, but this y has an exponent 1, this y has an exponent 2. They are not friends. They need x to the power 5y. Is there another x to the power 5y? No. 18x to the power 3y squared doesn't have a friend. So it seems like no one has a friend in this particular expression. So therefore that means all the 6 terms that we have gotten are basically the answer that we would conclude with as the final answer. Does that make sense? So this is how, guys, you would distribute. And if there were like terms, you would add and subtract those like terms by keeping the letters and the exponent as they are and adding and subtracting the coefficients. But here there are no like terms, so this is how we leave the answer with 1, 2, 3, 4, 5, 6 terms separated in that way. And that's that. Let's move on to the next question. 2x cubed minus 8 over x squared minus x minus 6 divided by 2x squared plus 6x over x squared minus 9. We have what here? We have the division of two fractions. And here there's a division sign. So guys, with division and multiplication of fractions, how do we attempt the questions? This division sign, first and foremost, needs to be changed. How? We keep the first fraction. We change or switch the sign from divide to its inverse. What's the inverse of division? Because we are going to change the divide to what? To multiply. Then f, we are going to flip the second fraction. We keep the first fraction as it is. Whenever there's a divide sign, the divide we switch or we change to multiply. And this second fraction we flip, meaning numerator becomes denominator, denominator becomes numerator. So let's do this first. That's the first step we do whenever we find ourselves in a situation where there's a division sign. Change divide to multiply, we switch or flip the second fraction. Just make sure when you write out, guys, you still have 2x cubed minus 8 as the original. You don't find yourself rewriting stuff and you rewrite them and things are missing. There's still x cubed, it's still negative 8, still x squared, still negative 6, still negative 6, still 2x squared at the bottom. Of course, now it's at the bottom, still plus 6x. You know, you don't drop the x because that's what changes the question, and then all of a sudden we get penalized for missing writing, you know, things that we should have written. X squared minus 9, still x squared minus 9, it's just that it's flipped now. After applying the KCF rule, we then need to apply factorization to our numerators and denominators of the two fractions. Now in factorization, guys, there are different types of factorization. Highest common factor, there's dots, there's cubic factorization, sum and difference of cubes. There is the trinomial factorization. Okay, if you are given ax squared plus bx plus c and the a is equal to 1, you know, specifically sometimes a is not 1 for a trinomial and you need to know how to factorize that. There's grouping factorization. So all these different types of factorizations need to be known very well. Okay. So you need to know these very well. So let's come here and look at this specifically. What do you see here? To factorize 2x cubed minus 8, what comes to mind? How many terms? You always ask yourself how many terms in an expression. There are 2 terms. Second question, should we apply the sign change rule? No, no need. Third question, is there a highest common factor between 2x cubed minus 8? Okay, yes there is. What is that highest common factor? The highest common factor is 2. Take out the 2. What's left inside? X cubed minus what? Minus 4. Okay. That's that. Over. Okay. If you look at the denominator, what is the expression here? There are 3 terms. What kind of expression is this? It's a quadratic trinomial. So here we can factorize how? We open 2 brackets. Okay. The sign of the constant is negative. That means we are going to have different signs inside the bracket. A negative constant means different signs inside the bracket. Then we think, do we have factors of 6, which when we multiply we get negative 6, but then when we add we get a negative 1? Well, what we know for a fact is that if the signs are different according to this negative sign means that the highest factor of the factors of 6 should be having a negative sign. So we are going to write 3 with a negative sign and 2. Since 3 is the biggest number, it will have the negative sign and 2 will have the positive sign. Now if we quickly check what's negative 3 plus 2, we get negative 1. The multiplication of negative 3 times 2 gives us negative 6. So x squared is formed by x and x. That's factorized. Okay. Times x squared minus 9. This is a difference of 2 perfect squares, because 9 is a perfect square number. X squared is a perfect square variable. Any variable that is raised to an even exponent is a perfect square variable. So what we do here, we are going to open 2 brackets. Since the negative sign is with the constant, we know we are going to put 2 different signs. 3, the square root of 9 is 3. So it's 3 times 3 that will give you 9. X squared is formed by the square root of x squared is x. That's factorized over 2x squared plus 6x. Highest common factor is 2x. What does that leave you inside the bracket? It leaves us with x plus 3. So we have completely factorized the numerator and the denominator of each expression in the numerator and the denominator, and the factorization is on point. Step 3, we cancel top and bottom, what we see as common, and we do so once if there's something that's common. So if you look at x plus 2, there's nothing that is common at the top and at the bottom. Okay, I just want to actually do the following here. Let's just slightly change the question. We know that x cubed minus 4 we cannot factorize any further. Okay, we can't factorize that any further. So if you cancel now, x minus 3 gets cancelled with x minus 3. Top and bottom you can cancel. X plus 3 gets cancelled with x plus 3. Top and bottom you can cancel. 2 gets cancelled out with 2. Top and bottom you can cancel. When you cancel and there's nothing you think is left, you actually leave in the place of what you have cancelled a 1. So now at the top we have 1 times this bracket times 1 times 1. That gives you x cubed minus 4. And the denominator, you have 1 times x plus 2 times x. Okay, 1 times x plus 2 times x. That leaves us with x into x plus 2. So the denominator, we are told we can leave as an expression of basically 2 factors. That's fine. X cubed minus 4 is all together. So basically we leave our answer like this. This is how you simplify, guys, when you are dealing with the division of 2 algebraic fractions. You apply KCF. I'm sorry for the rumbling stomach, guys. I am extremely hungry. I've just woken up, of course, haven't eaten breakfast, and I will not be having breakfast. So you apply KCF, you keep the first fraction, you change the division sign to multiply, and you flip the second fraction as you see us do there. That's a mark, guys. We changed divide to multiply, this fraction was flipped. This one remained that way. After doing so, we apply factorization to the what? You apply factorization to the numerator and the denominator of your fractions respectively. And please, guys, step by step you factorize. This cannot be factorized any further because though this is a cubic term, 4 is not cubic. You know, yeah, the cube root of 4 does not give me a natural number. So therefore, that's why I'm not factorizing this any further. Okay, you cancel common brackets, top and bottom. Guys, you only cancel if top and bottom there's something common. That's why we cancel that and that, top and bottom once, we left with 1. Cancel x plus 3x plus 3 once, that's why we left with 1. Cancel 2 and 2 once, top and bottom, we left with 1. Then this x is left behind. That x cubed minus 4 is left behind. The x plus 2 is left behind. So we multiply at the top, we get x cubed minus 4. We multiply at the bottom, we get x plus 2 times the x is x into x plus 2. I know some people would insist on actually going ahead and writing the answer as x squared plus 2x, meaning they take the x and distribute it into the denominator. I mean, guys, that's fine. But I think they say it's fine if you leave it with the denominator with x into x plus 2. Rather, make sure you simplify the numerator and you can leave the denominator like that. Okay. All right. This is not too bad, was it? Okay, let's move on to this question. 9 times 3 to the power x plus 2 plus 5 times 3 to the power x over 3 to the power x minus 3 to the power x plus 1. What you notice here is what we have here is an exponential expression. In the numerator, you have a plus sign. There are 2 terms in the numerator. In the denominator, you have a minus sign, meaning there are 2 terms in the denominator. So with this exponential expression, we are simply going to do the following. We are going to check, have a sense of awareness of what's happening in the numerator. There's a 9 times 3 to the power x. So base 3 has the coefficient x as an exponent for the variable x. We have the coefficient 1. Base 3 has the coefficient 1 for the x. So basically it means I'm going to be taking out some common factor. But before I do that, I'm going to split or expand what is in the numerator when it comes to certain exponential terms. So 9 can be written as 9, that's fine. 3 to the power x plus 2, I'm going to split to become 3 to the power x times 3 to the power 2. 3 to the power x times 3 to the power 2. You know the law that says if bases are the same and you're multiplying, you keep the base, you add the exponent. So I'm just writing this in reverse. I'm expanding this to 3 to the power x times 3 to the power 2. Or in other words, I'm splitting this to 3 to the power x times 3 to the power 2. I know, guys, that the minute I have a plus and a minus sign, in my head, I think of factorization. Some factorization will have to be applied somewhere. Okay, that's why, because at the top there's a plus sign, the bottom there's a minus sign. So let us first expand and split. So that's our splitting done at the top. Let's come to the bottom and do the same. We have 3 to the power x minus, let's split this guy to 3 to the power x times 3 to the power 1. Okay, are we good? Was the splitting manageable, doable? Okay. Let's continue. Now in the numerator, we can take out the base 3 to the power x. Take it out. What's left on the left hand side? It's 9 times, there's a 3 squared, 9 times the 3 squared, which I know 3 squared is also 9. So it's like we are left with 9 times 9 here on the left. Then there's a plus sign. What are we left with on the right? In the place, there's 5 times the 3 to the power x that was there leaves a 1. So it's 5 times 1. I hope you understand that, guys. I repeat again. You take out 3 to the power x. You deliberately take out the base that has the variable exponent and all the numbers. Guys, you just make sure you pump the numbers inside. Don't take out the other numbers. Just leave the numbers inside, even if the numbers are common, but just leave the numbers inside. Okay, let the numbers deal with the numbers, and let the base with the variable exponent deal with the base with the variable exponent. At the bottom, who is common? Okay, 3 to the power x is common. What do you get left with inside? Okay, you take out 3 to the power x because it's common for the both terms. You are left with what on the left? 1. In the place of 3 to the power x, it's 1. Minus, in the place of that 3 to the power x, it's also 1 times which one? This 3. Okay. Now, guys, after taking out the highest common factor, which is the base with the variable exponent in this situation, that base with the variable exponent can now easily be cancelled. That base with the variable exponent can easily now be cancelled, because the relationship of 3 to the power x with the bracket is multiply, the relation of 3 to the power x with this bracket is multiply. So we can easily now cancel this 3 to the power x, which leaves in the place of 3 to the power x and 3 to the power x a 1 at the top and at the bottom. Don't be afraid of math stylish. There's no need to. Now inside this bracket, we can simplify. 9 times 9, that's 81, plus what? 5 times 1, that's 5. We do this simplification according to board math. 9 times 9, multiplication comes before addition. 9 times 9 is 8, 5 times 1 is 5, over 1 minus, what's 1 times 3? It's negative 3. Okay, so 81 plus 5 is 86. 1 minus 3 is negative 2. And then, of course, we divide 86, that's positive, with negative 2. So a positive divided by a negative is a negative, obviously. 86 divided by 2 gives you 43. And that's your final answer. Okay. So 3, you cancel common top and bottom. Anything that's common top and bottom, but we don't cancel across an addition and a sum. We don't cancel across an addition or subtraction sign. We don't ever do that. Be careful. So that's why, for instance, we don't cancel at this stage. We first take out the common factor. Okay, take out the common factor, the base with the variable exponent. We first take it out. Then we can see 3 to the power x is multiplied. Now, with multiplication, cancelling is possible. There you cancel nicely. Then you are left with 9 times 9 is 81, 5 times 1 is 5. 1 minus 1 times 3 is 3. So 1 minus negative 3 at the top. 81 plus 5 is 86. 1 minus 3 is negative 2. You simplify, you get negative 43. And that's how you basically get your answer. Simplify, then your answer nicely. Okay? Easy, grade 10s. Easy, easy cappies. Let's move on to the next question. Next question has to do with factorize. Factorize fully the following expression. How many terms do you have? 1, 2, 3, 4. What do you see is common for all 4 terms? There's a 2 here, there's a 2 there, there's a 2 there, there's a 2 there. So the first thing you do is you are like, there are 4 terms. The sign change rule does not need to be applied, but there's a highest common factor we can take out, so we take it out, the highest common factor. What are you left with then for the first term? X squared. What are you left with the second term? Plus px. What are you left with the third term? Minus mx. What are you left with the fourth term? Since you took out 2, you are left with negative mp. Okay. Inside the bracket now, with the 4 terms that you have, what can you do now? You look at the 2 terms, you group them, and you factorize. So in your head, you are going to be grouping these first 2. So you keep the 2 there outside, no problem, right? And then you can take out the common factor between these 2 terms, which is what? X. Okay, so what we do, we are going to use a different set of brackets. We're going to use square brackets here so that we can differentiate between. Okay, so we are going to use square brackets. Change these to square brackets just so that we can actually differentiate and distinguish between the other brackets. So for these 2 terms, the common factor is x. What that leaves you with on the left is x plus p. When I take out the x for these first 2 terms. These last 2 terms, we're going to do the same thing. Take out common factor between these 2 terms. We call this grouping, guys. We group these first 2 terms, the pair of terms, and we group this pair of terms. Now remember, when we take out a common factor for 2 terms where the first term is negative, we always take out the negative sign as the highest common factor. M and M is common, we take out M. What does that leave us with inside? A x. A negative times what gives you a negative? That's a positive. A negative times a positive gives me. So the minute you take out a negative sign, the signs of each term, they change. Where there was a negative, we now have a positive. Where there was a negative, we now have a positive. Plus what? Plus p. Are we together, guys? Okay. We first took out the highest common factor for all 4 terms because we saw that 2 was common for all 4 terms. Then secondly, we grouped because we could see that for the 4 terms inside the bracket, each pair exhibits a common factor that we can take out. That grouping leads us to highest common factor factorization with the pair of terms, and that leads us to a common bracket that we can now actually take out from the, how many terms inside the bracket? 1 minus sign separates 2. So we can see there's a common bracket of x plus p, which we can now take out additionally. So we are going to say 2 is already out, but now x plus p can also be taken out for these 2 terms. X plus p is a common bracket that can be taken out as well to join the 2. What is left on the left if I take out x plus p? I am left with an x on the left. What is left on the right if I take out x plus p? I'm left with a negative m. And this is basically my final answer of factorizing this 1, 2, 3, 4 terms. Take out the common bracket and then leave. If I take out x plus p, I'm left with x on the left. Take out x plus p, I'm left with x on the left. There it is. If I take out x plus p on the other side, I'm left with negative m on the right. And that is basically my factorization complete of the 1, 2, 3, 4 terms that I had. 4 marks. I can get all of it. It's mine. It's mine. All of it. Okay. Yeah, guys. Hi, that's is nice, guys. Maths is nice and easy. Look at the next question. Look at the next question. Here, what do we have? We're supposed to factorize, so let's analyze what we have. We have 8 to the power 3 over 125. Guys, when I look at 8, I can see 8 is a perfect cube. A is also a perfect cube because it is a letter raised to the power 3. 125 is a perfect cube. Okay? Then there's a minus sign, then there's b cubed. B cubed is also a perfect cube. So what do I have here? I have factorization of what kind? This is a difference of 2 cubes. Difference of 2 cubes, DOTC. So when I factorize a difference of 2 cubes, I'm going to start out by opening a binomial bracket with a trinomial bracket. That's where I start. I start right there. Then, since this is perfect cube at top, perfect cube at the bottom, what I'm going to do, I'm going to ask what is the cube root of 8. Cube root of 8, guys, is 2. What is the cube root of a cubed? Cube root of a cubed is a. What is the cube root of 125? Cube root of 125 is 5. That is going to be my first term for the binomial bracket. Since there's a minus sign, keep that minus sign. What is the cube root of b cubed? Cube root of b cubed is b. So what I have in my first binomial bracket is simply me finding out what is the cube root of 8, it's 2. Cube root of a cubed, a. Cube root of 125, 5. I keep the minus sign as it is. Cube root of b cubed is b. Basically, when we are factorizing a difference of 2 cubes, this is what we do, guys. We open a binomial bracket. The same sign that was in the expression is the same sign you are going to have for your first bracket. And you simply find the cube root of the numerator, cube root of the denominator, cube root of the b cubed there. Followed by, if you want to know the signs here, if it's minus sign first, you follow it with plus and another plus sign. Now, someone is going to ask, so what if there was a plus sign for the sum of 2 cubes? Then you would have a sum here with the same terms. And then here you would have a minus plus. So the only thing that changes really is this sign here. If it was a plus there, you would have a plus, minus, plus. But since you have a minus here, you have a minus, plus, plus. That is always the case with the signs inside your bracket, guys. If you have a difference of 2 cubes, you will have a minus, plus, plus. If it is a sum of 2 cubes, you are going to have a sum, plus, minus, plus. So what we know for a fact is that the last term is always positive for the trinomial bracket. Then you square 2a. What do you mean by square 2a? You take 2a and you square it, you get 4a squared. So that means in the numerator, 4a squared. Remember, 2 times 4 is 8. 8 times a squared, that's what gives you a cubed. Over 5 times what gives you 125? You square 5, you get 25. And it is 25 times 5 that will give you 125. The last term, you square the last term, you get b squared, because it is b, negative b, times b squared, which will give you back the b cubed. How do you find the middle term? It's simple, guys. You simply forget about this sign and you multiply the 2a over 5 with the b. So you say 2a over 5 times b. This b is in the numerator. So your final answer is going to be 2ab over 5. So you write here 2ab over 5. The product, the multiplication of these two terms with ignoring the negative sign, that's how you get the middle term. I'm glad, Cynthia, that it's easy for you. Keep it that way and hopefully you do well. let's come to this last question here. Here we are supposed to do what? Also, we are supposed to factorize fully. So what do we do here, guys, in order to factorize fully? This is kind of like a tricky question, really. Kind of needs your brain. 179 we can see here. Here we see 1979 we can see there. We can see here 1978 squared minus 1. We need to simplify this. So what do? You say 179. This can be written as 178 plus 1 if you think about it, because 1978 plus 1 gives you back 1979 over, this is a difference of two perfect squares. This is squared minus 1 is a perfect square. So that means I can apply difference of two squares in the sense that the square root of this is 1978. If I multiply that 1978 with another 1978, I get back this thing squared. Okay, square root of 1 is 1 and 1. When you are factorizing a difference of two squares, you put a plus sign for one bracket and a minus sign for the other. Now what do you see now, guys? What you see here is just simply the cancellation that you can do, because the top and the bottom bracket are common. What does that leave you with? It leaves you with an answer of, when you cancel, you are left with 1 and 1 over. Now 1978 minus 1, that gives you 1977. That is our answer that we get for this particular problem. So this problem requires you to think outside the box. Easy for learners to think that this is difficult, but in all honesty it's not. I can see here at the bottom with numerical values that are very high, they have actually indicated a difference of two perfect squares. This number is squared, the 1 is a perfect square. So we can apply a difference of two squares factorization in the numerator. Because we can anticipate the turnout of the difference of two squares factorization at the bottom, we can rewrite 1979 as 1978 plus 1, because that addition gives me back that 1979. Then you see the common bracket that I can cancel out, because cancellation happens top and bottom as long as it is not across an addition and a subtraction sign. The relationship between these two brackets is multiply, and these two terms at the top are common with the bottom bracket. You can cancel that and cancel that. We're left with 1 and 1. Remember, the 1 in the numerator is significant, it remains, but in the denominator 1 does not hold significance. So 1 times whatever you get there is 1977, and that's how you simplify that question with no problems. Let's move on, guys. Moving very swiftly and smoothly. Okay, to the next question. Solve for x. Okay. 8 into x plus 1 minus 7x is equal to 7 into 3 minus x. So when we look at this, on the left we have 1 minus 7. 1 term, minus sign, 2 terms. On the right, we have 1 term. So here, we first start out by distributing the 8. 8x plus 8 minus 7x. Already we can see like terms are there. We'll deal with them later. We distribute the 7 to the 3 and the minus x. We get 21 minus 7x. Then the variables with the like terms, 8x minus 7x, you take the negative 7x over, plus 7x is equal to 21. Take the 8 over, it's positive. When you transpose the 8 over to the right hand side, it becomes negative. Then you add your like terms on the left. This leads you to a linear equation because the x has no exponent, that is 2, x as an exponent 1 for all three terms. 8x minus 7x plus 7x, that gives you 8x. 21 minus 8, that gives you 13. Then you divide both sides by the coefficient of x, which is 8. Then you get an answer, which is 13 over 8. And that's done. Okay. Straightforward, as straightforward as can be. If you look at the next question, solve for x. 6x squared minus 5x is equal to 6. Okay. So 6x squared minus 5x is equal to 6. Okay. Step number 1. With a quadratic, this is not a linear equation, this is a quadratic equation. We must first write the equation in standard form, meaning in the form ax squared plus bx plus c is equal to 0. So here, we first write the equation in standard form. Take the 6 over, we have 0. Okay. Then 2. We factorize, apply factorization to the trinomial. So here, this is the kind of trinomial that has a coefficient that is not 1. So therefore, it means we are going to apply a rule that is applicable. Whatever rule you have learned at your particular school, please use that rule to be able to factor, that particular trinomial. So I use the AC method, which is a bit long, which is fine. It ensures that I get the answer. I'm going to take this A value, which is 6, and multiply by negative 6, which gives me negative 36. So A times C, that's 6 times negative 6. That gives me negative 36. Then I'm going to find the factors of what? Of negative 36, right? Which when I multiply, give me negative 36, but then when I add them together, they should give me a negative 5. I repeat, when I multiply these factors, they need to give me negative 36, but when I add them, they need to give me negative 5. So you think, what are those factors? We have 9 and 4, we have 12 and 3, we have 6 and 6, 36 and 2. But I can see clearly that this one will work. The signs of those factors are going to be because of the negative sign. If you have a negative value that comes from the multiplication, it means you are going to have different signs. You want, when you add these two, to get negative 5. That means the sign of the biggest factor will be negative and the other one will be positive. You can then place x and x there, and you choose these, you take them, they go and replace negative 5x. So I'm going to rewrite this negative 5x, I'm going to replace negative 5x with negative 9x plus 4x, because that does give me negative 5x. Okay. Does that make sense? So you replace this negative 5x with those factors. Okay. Negative 9x plus 4x replaces negative 5x. Then you can now group and factorize, pair terms that have a factor, a common factor, highest common factor, and you group factorize so that you can have a common bracket. So I can group these two terms and group these last two terms. If I take out the common factor here, I take out 3x as a common factor, because between 6 and 9, the highest common factor is 3. Between x squared and x, the common base with the lowest exponent is x. I take it out. What's left inside? 2x minus what? 3 times what gives you 9? It's negative 3. Look at these two terms. The first term is positive, so you take out a positive what? 2 times 4 and 6. What is the highest common value between 4 and 6? It's 2. What are you left with inside? 2x, minus 3. What do you see now? Common bracket. So you take out the common bracket, 2x minus 3. If you take out 2x minus 3, what are you left with on the left? 3x. What are you left with on the right? Take out 2x minus 3. plus 2, which is equal to 0. Then from there, guys, you can simply now, these guys are your what? Are your factors. Having factorized, these are your factors. These factors, when you FOIL them back, you should get back that trinomial. You see? Now you can apply what we call the zero factor law after factorizing. If you have a product of factors and there's 0 on the other side, you can now take 2x minus 3, make it equal to 0, 3x plus 2, say it's equal to 0. Then you can solve each linear equation on its own. Okay, and solving each linear equation on its own means isolating the x on the left, transposing the other term, 2 becomes negative 2, negative 3 becomes 3, then you divide both by 2. By 2 for this side, because the coefficient of x is 2, you divide by 3 here, the coefficient of x is 3. Then your final answer is what? X is equal to, the first answer is 3 over 2. The second answer is x is equal to negative 2 over 3. And that settles that. Okay, so guys, standard form, to factorize factors, obviously with this method I was able to eventually get to the factors. Some people are able to get the factorization done without going through this method. Whatever method you use, guys, please make sure as a grade 10 learner use an appropriate method to get to the factors. Once you have those factors and they are equated to 0, you can then apply what we call the zero factor law. This law is applied when there's a 0 and there's a product of factors. You take one of the factors, each you equate it to the 0. You can only do that when there's a 0, not when there's another number. When there's another number, you have to first FOIL, take the number over, refactorize, and then you can apply zero factor law only when there's a 0 on the other side. So 2x minus 3 is equal to 0, or 3x plus 2 is equal to 0. You can then get the answer. X is equal to 3 over 2. X is equal to negative 2 over 3. Let's move on. We are here now. Solve for x. This is an exponential equation. 2 to the power 3x plus 1 is equal to 128. Guys, 128. Can we convert 128 so that it has a base? Let's prime factorize. 128, we go press 128, we press equal, we press shift, then we press fact. See, 128 is actually equal to 2 to the power 7. Then 2 to the power 3x plus 1 is equal to 2 to the power 7. The law or the rule says if a to the power x is equal to a to the power y, when bases on either side of the equal sign are the same, you can drop the base and you can equate the exponents. So you can say x is equal to y if the bases are the same. So since the bases are the same, it's both 2 and 2, we can say 3x plus 1 is equal to 7. Then we can solve the equation. Isolate the x, 7, take the 1 over, 7 minus 1, 3x is equal to 6. We then divide both sides by the coefficient of x, which is 3. Then x is equal to what? 6 divided by 3. It's 2. Simple, straightforward, just like that. Marks in the back. We don't leave any marks behind. Oh my soul. What was the question for this inequality? Okay. I somehow omitted to write the question for this. Solve the inequality and represent your answer solution graphically, right? Yeah. Okay, so let's solve the inequality and then represent our answer or solution graphically. So let's look at this. We have a negative 9 less than equal to negative 2x plus 3. So what we have here is we need to first try and isolate the x variable here. How? The plus 3 must go how? We apply the additive inverse. We minus 3 here. So that if we minus 3 here, because this is a plus 3, we minus 3 here, we are left with negative 2x. But if you minus 3 here, you have to minus the 3 there as well. 5 minus 3 is 2. You minus the 3 there as well. Negative 9 minus 3 gives you negative 12. That's the first step. You apply the additive inverse. Since it's plus 3, we are going to subtract 3. If it was minus 3, we are going to add 3. But remember, whatever we do here to eliminate this plus 3 is what we are going to eventually do this side. So since this is plus 3, we have to subtract 3. We are going to subtract 3 here. 5 minus 3 is 2. We are going to also subtract 3, and negative 9 minus 3 is negative 12. Negative 2x is isolated. We are now going to divide by a negative sign. Now, division by a negative sign does something to the inequality signs. Division by a negative leads to a change in the direction of the signs. Okay, we reverse the signs. Less than equal to becomes greater than equal to. Less than becomes greater than as well. Negative divided by negative is positive. Positive what? 12 divided by 2 is 6. The division leads us to x. Positive divided by negative is negative. 2 divided by 2, that is 1. Then negative 1 needs to be written on the left. This sign was opening its mouth towards x. It continues to open its mouth towards x. This sign was opening its mouth towards 6. It continues to open its mouth towards 6. That is our answer as an inequality. Now we need to represent this answer graphically. So then we are going to write a number line, have negative 1 there, have 6 there. For the inequality sign that has no equal sign, we draw an open dot, because no equal sign means open dot. For the inequality sign that has an equal sign, we draw a dot, but then we shade it in, because that is to say that 6 is part and parcel of the answer. It's included. No equal sign means negative 1 is not part and parcel of the answer. It's not included. Then x is greater than negative 1 but less than or equal to 6. That is everything in between negative 1 and 6. That can be actually indicated or taken into account as an answer. And that's basically how we represent our answer in number line. Please guys, straight line, not a wiggly line as you see me have. You use your ruler, you connect those two dots, and that's basically the representation of our answer. Look at this question. Solve for x and y simultaneously. Very interesting, this one, because it's 2 to the power x plus 2, which is equal to 8 to the power 2y minus 1. And then this second equation is 3x plus 2 is equal to 4y plus 1. So this is an exponential equation, very different from what we are accustomed to in grade 10. But what we can do first and foremost is take this equation and actually, using our laws of exponents, take care of it. So 2 to the power x plus 2, equation 1, we are going to work on 2 to the power x plus 2 is equal to, the 8 can be written as, if you go to your calculator, you say 8 is equal to shift, then you press fact. 8 can be expressed as 2 to the power 3. So in brackets, we are going to write 2 to the power 3, 2y minus 1 outside the bracket. Then as we simplify further, we get 2 to the power x plus 2. We take the 3, okay, we distribute it to the 2 terms, which is why I love putting the exponential expression in brackets, so that you know that 3 is supposed to be multiplied by 2y. So we have 2 to the power 6y. 3 is supposed to be multiplied by -1. You have -3. Bases are the same. According to what I said earlier on, when the bases are the same on either side of the equal sign, what can you do? You can drop the bases and equate the exponent. X is equal to y because the bases are the same. The bases are the same. I can then say it's x plus 2 is equal to 6y minus 3. The exponential is now represented as a linear equation. And then let's make one of the variables, x or y, the subject of the formula in this very same equation. What's nice is that I can already see x. I can isolate it. X is equal to, take the 2 over, it becomes 6y minus 3 minus 2. The 2 that is positive changes from positive to negative. So x is equal to 6y minus 5. That is going to be my equation 3. Okay, I think I'm on the right track. Do you see what I did here? This is my equation 1. I took him, I sebenzed him, worked on him. Base 2, 8 in brackets. Applied my exponential law number 3, distributed the 3 to the exponential expression. 6 3 times 2y, 6y 3 times -1 is -3. And I got that. Bases are the same on either side, dropped them, equated the exponent. The x plus 2 is now there, 6y minus 3 is now there because the base 2 are the same. Then I made x the subject of the equation so that I can get my equation 3. Equation 3 now will be substituted into the equation that was not touched. I call this the virgin equation, untouched. You take that x is equal to 6y minus 5, you go and substitute it. Where x is, you are going to substitute in this equation. Where x is, you are going to substitute in that equation. Where x is. So let me quickly do that for you so that you can see it. X is equal to 6y minus 5. You are going to substitute that into which equation? The equation that is 3x plus 2. Guys, when you write out, make sure you write out correctly. You don't make errors because you wrote the wrong equation. So where x is, I'm going to substitute 6y minus 5. So where x is, I'm going to write 3. Where x is, I'm going to write 6y minus 5 plus the 2 is equal to 4y plus 1. I continue, distribute the 3. 3 times 6y, 18y. 3 times -5, -15 plus 2. 4y plus 1. Then you add and subtract the like terms. 18y, you take the 4y over, minus 4y. 1, you keep on the left. 2, you take over, -2. -15, you take over, you transpose. The signs, they change. Plus 2 becomes -2, -15 becomes plus 15. 18 minus 4 is 14. 14y. 15 plus 1 is 16. 16 minus 2 is 14. Then you divide both sides by the coefficient of y, which is 14. Y is equal to 1. But you're not done. You are going to sub y is equal to 1 into which equation? Into the equation 3, which is basically this equation. Y is ready to be substituted so that you can get the x value. So we say x is equal to 6. In the place of y, we substitute 1 minus 5. What's 6 times 1? It's 6 minus what? 5. What's 6 minus 5? It's 1. So therefore that means where x is 1. Y is also 1. Let's not forget, guys, that the values of x that you get here and y are basically your points of intersection if you were representing these in the form of a number line. Okay, we are basically getting to the end of this particular question paper. Just bear with me. Make t the subject of the formula in the following equation. Make who? Make t the what? The subject of the what? The formula in the following what equation? Here's the equation. At plus x over b is equal to 5. So what we want to do, we want to isolate t. But at the moment, t is multiplied by a added with x all over b. So we want to get rid of all these other things so that t is alone on the left. But we want to do it in order without compromising the rules of mathematics. So the first thing we want to do is get rid of the b. To get rid of the b, where is the b? The b is in the denominator. So how do we get rid of it? We are going to multiply both sides by b. Multiply by b in the numerator because this b is in the denominator. When that happens, what happens? The b and the b, they cancel. So we have now at plus x is equal to, what's p times b? pb. Step number 1 has been done. We just applied the multiplicative inverse. To get rid of a b in the denominator, we multiply by that same b, not in the denominator, but in the numerator. But in equations, what you do on the left, you must do where? On the right. So now we have at plus x is equal to pb. Next step, let's isolate at. Take x over, it becomes pb minus x. We transpose x to the left-hand side, to the right-hand side. From the left to the right, x becomes negative x. We are so close now to getting t to be on its own. How do we get rid of this a that is multiplied to t? We simply divide both sides by what? By a. What we do on the left, we do on the right. The a and the a cancel. We are left with t. T is equal to what? pb minus x over what? Over a. There we go. We've just made t the subject. We made t the subject of the formula in the following equation by simply first applying the multiplicative inverse, all in the hopes of getting rid of b. That was the first thing. We always multiply in the opposite position. If the b is in the denominator, it's divided, we multiply by b in the different numerator. And then what we do on the left, we do on the right. Get rid of the x, we transpose it. Get rid of the a, we divide by it. So we transposed here, which is the additive inverse. Additive inverse, behind additive inverse, or let me say hiding transposition is the additive inverse. And then lastly, we then divided. Once again, we applied the multiplicative inverse. The current a was in the numerator, so we divided by a, where in the denominator, the opposite position. Applied the multiplicative inverse, we got that. Look at this question. The perimeter of a rectangle is 24 meters. Enormous perimeter is given by this formula. 2 is equal to L plus B. So that means 2 is equal to L plus B is equal to 24. Let's just accept that. They are saying the perimeter of a rectangle is 24 meters. So formula-wise, this would be what it looks like, because we know that the perimeter of a rectangle is 2 into length plus breadth. In other words, here is the rectangle. Length is the longest side of the triangle, breadth is the shortest side of the triangle. So you add, perimeter means the distance around a particular shape. So that will be L plus B plus B, which will give us basically 2 lengths plus 2 breadths, which basically you can say is 2 into length plus breadth. Okay, so we are told the perimeter of a rectangle is 24 meters. This is what that means. Its length is thrice the breadth. So the length is 3 times the breadth. Determine the length and the breadth of the rectangle. Do you see this, guys? So we have two equations here. We are told that the perimeter of a rectangle is 24 meters. But then we are told its length, meaning the length of the rectangle, is 3 times, okay, it's thrice the breadth. This is what it means. Length is equal to 3 times the breadth. Length is thrice the breadth. So we can actually now come up with two equations. The equation that was formed because of perimeter is 2 into length plus breadth is equal to 24, which is basically 2 lengths plus 2 breadth is equal to 24. That was my equation 1. Then equation 2 I formed because it says the length is thrice the breadth. Length of the rectangle is thrice the breadth. That's equation 2. Okay. So I'm going to take equation 2. It's already, subject is L. L is equal to 3b. So I'm going to substitute now equation 2 into equation 1. Take this guy, substitute into equation 1. That means where L is, I'm going to substitute 3b. Where L is, in the place of L, I'm going to substitute. In the place of L, I'm going to substitute 3b. 2 into, in the place of L, we substitute 3b plus 2b is equal to 24. Okay. Angeli, Angel, is it Angel? Where are you from? Where are you from? Okay. So each, you see, length is equal to 3b. In the place of L, I substitute 3b. 2 times 3b plus the 2b is equal to 24. All right. 2 times 3b, that is 6b, plus 2b, which is equal to 24. Now I can actually find the breadth. 6 plus 2b, that gives me 8b, which is equal to 24. I then go ahead and I divide both sides by the coefficient of b, which is 8. Okay, so I'm in South Africa, Kerala, Kerala. Okay, and I am basically, the learners this side are writing mathematics. This is like I don't know what's the equivalent of the classes in India. I don't know how the system goes in India, but here in South Africa we have a high school phase, which is like grade 10, high school phase, which is grade 8 to 12. So like this is like your grade 10 mathematics, and specifically that's like the third last class before one completes high school. So it's that kind of mathematics. Okay. By the way, thank you for popping in. I really appreciate you. I mean, from India. That is quite touching. Oh, you're in the 8th. So that is actually, so that would actually be the equivalent, because I guess that's the 8th. How many classes do you guys have in high school? Sorry, what is the last class in high school for you guys? Maybe you can let me know that, and then well, I'll have an idea. But yeah, so we do the same here. So 8 divided by 8, that's 1. So you're left with b. What's 24 divided by 8? You have 10. So this is, it's the equivalent then. So if you have 10 standards, in the old South African system, we had standard 8. So this would be the equivalent of standard 8. We call it grade 10 now. It's kind of like the introduction of the new system. Yeah. So it's the same, it's the equivalent mathematics. 24 divided by 8, that is 3. But your guys' standard of maths might be higher. Who knows? I don't know. Like, it just depends, because our syllabus is like this. Okay. So b is equal to 3. So the breadth is equal to 3. Then we want to find the length. Remember, we take the equation 2. We go and substitute the b is equal to 3 into equation 2. We can go back and substitute b is equal to 3 into this equation because that equation is ready to give us the length when we substitute the breadth. So we say L is equal to, in the place of b, we substitute 3. We're going to say 3 times 3, which is 9. Okay, so we can then conclude and say, because the question was, determine the length and breadth of the rectangle. So the breadth is actually 3 meters, whilst the length is equal to 9 meters. And that completes that question nicely. Let's just recap on it. The question said the perimeter of a rectangle is 24 meters. Its length is thrice the breadth. Determine the length and the breadth of the rectangle. So from my first statement, the perimeter of a rectangle is 24 meters. I basically then wanted to say, okay, perimeter, what is perimeter? That is the total distance around my shape. And I know that for the perimeter of a rectangle, you are adding the 2 lengths plus the 2 breadths. 2 into length plus breadth, those are the 2 lengths plus the 2 breadth. That is equal to 24. We can set up that equation using perimeter. Its length is thrice the breadth. So a second equation you can write is the length of the rectangle is thrice. Thrice means 3 times b. The word thrice means 3 times. So you say length is, meaning L is equal to 3b, 3 times the breadth. Now they want you to determine the length and the breadth of the rectangle. So you set up 2 equations. The first one for the perimeter, the second one comparing the length and the breadth. And then basically you take these 2 equations and what do? You basically use them, solve them simultaneously so you can get b, okay? And then you can get the length as well. And you conclude at the end, okay? I think now this is the dying last question, trigonometry. We are told in the quadrilateral below AD is equal to 12 units. AB. Okay. AB is equal to 12 units. There you can see. And DC is equal to 3. DAB and DCB. DAB. Yeah, you see, I think the wording here is off. Okay, I think I'm gonna hold it right there because the wording is off. DAB. Yeah, this is supposed to have been DBA. So DBA and DCB are 2 right angles. That makes sense. On the quadrilateral ABCD. Calculate the length of DB. Calculate the length of DB. Now, triangle DAB is a right angle triangle. What do you have given to you? You have AD that is given to you, which is 13. And you have AB given to you, which is 12. The question says calculate the length of DB. What can we use to calculate the length of DB? We can use the theorem of Pythagoras. What does the theorem of Pythagoras say? The theorem of Pythagoras says that the square of the hypotenuse side, in this case, what is the hypotenuse side? It is AD. Why do we know AD is the hypotenuse? Hypotenuse side is always opposite the 90-degree angle. So this triangle ADB, that's why I'm going to say in triangle ADB. I notify my teacher who's going to be marking that I'm working in triangle ADB because we have a quadrilateral here, but I'm working in triangle ADB to find the length of DB. What do I see there? I have the length of DA, I have the length of AB. I'm missing DB, so I can use Pythagoras. Pythagoras says the square of the hypotenuse side, the square of the hypotenuse side is equal to the sum of the square of the other two sides. The sum of the square of the other two sides. And when you use Pythagoras, you make sure to write the reason Pythagoras. So AD squared, AD guys is 13, we square that. AB is 12, we square that. DB, that's what we want, all right? 13 squared, 169. 12 squared, 144. DB squared, we just retain the square for DB. We use our laws of transposing. Two terms on the right, we transpose the 144. The sign changes to negative 144. That's DB squared. What is the answer here? 25. And we have DB squared. We want DB, not DB squared. So we take the what on both sides. The square root, we put plus minus because this is an equation. Then the square root of 25, that gives us 5, plus minus 5. DB is equal to positive 5, or it can be negative 5. But because this is a length, guys, we know that a length can never be negative, so we take only the positive answer, that is 5 units. Then we can fill in our diagram, DB is 5. That is basically us calculating the length of DB. Next question says, what is the length of BC? We go there. Where is BC? Here is BC. Okay, it is in triangle DBC. So we go and say in triangle DBC, we want the length of BC. We've updated our diagram. DB is 5. We want BC. So now we are going to still use which theorem? The theorem of Pythagoras. What is always opposite the 90-degree angle is the hypotenuse. So the hypotenuse for triangle DBC is DB. All right. So theorem of Pythagoras we're going to apply so that we can find the length of BC. We have two lengths, we have one missing one. So we're going to use the theorem of Pythagoras again. What are we going to say? BD squared this time around. The square of the hypotenuse side is equal to the sum of what? The square of the what? Of the other two sides. So we say BC squared plus what? DC squared. Pythagoras. What is BT squared? We say 5. What is BC squared? We don't know yet. That's what we want to find. What is DC squared? DC squared. DC is 3, so we're going to say 3 squared. We want to isolate BC because we want to find it. We transpose the 3 squared. So we're going to have 5 squared minus 3 squared, which is equal to BC squared. 5 squared minus, that's 25 minus 9, which is BC squared. That means BC squared, guys, is going to give us, what's 25 minus 9? It is 16. We then take the square root on both sides. We put plus minus. We know BC squared, square root of 16, that's positive or negative 4. That is BC. But since this is a length, we know that it cannot be negative, so that means BC is equal to 4. 4 what? Units. Okay. We go and update our diagram. 4 units, definitely there. We now have all the lengths of the triangle that basically make up the quadrilateral. Let's continue. Write down the size of angle ADB in terms of 90 degrees and angle A. Write down the size of angle ADB. When they say ADB, guys, our focus is here. ADB. ADB. So we want the size of this angle, and this thing is saying in terms. In other words, in the answer, you have to have 90 and you have to have angle A in that answer. So we are going to go to this triangle and we are going to say in triangle ADB. If we are looking at the length, if we're looking at the angle ADB, the angle that they want me to find, what can I say? I can say angle ADB plus angle A plus 90 degrees will give me 180 degrees. What's the reason? Sum of angles in a triangle. Then let's isolate ADB. Take the 90 and the A over 180 degrees minus 90 minus angle A, which gives us what? What's 180 minus 90? It's 90 degrees minus angle A. So ADB, angle ADB, is now written in terms of 90 and angle A. It's 90 degrees minus A. That is the answer that they wanted from us. So I can go there and write in the place of angle ADB 90 minus A. In terms of D, angle D, ADB can be written in terms of 90 and A. Angle D can be written as 90 degrees minus A. Let's finish off, guys. Very, very last thing that we need to do and take care of. You see, all the information I got from the answers that I got, I fill in the diagram so that I have the elements filled in. You update your diagram so that your diagram can serve you in the next and the next question. 4.3.1. Write down the value of tan A. Now, where? You always ask yourself, where is angle A? Here is angle A. Which triangle? Triangle ADB. So my focus is on triangle ADB. They want the value of tan of A. So my question first, I ask, where is angle A? It is in triangle ADB. So there it is. You must know where angle A is. That's important. 2. What is the definition of tan? So you know most, you have SOHCAHTOA that can remind you of the definitions. Tan is opposite over adjacent. So in your head, you know there's opposite at the numerator, adjacent in the denominator. So the question then is, what is the opposite side in reference to the angle? Most, you know where A is. What is the opposite side in triangle ADB as far as this angle? The angle opposite angle, the side opposite angle A is DB, which is 5. So the opposite side is 5. 5 in the numerator. What is the adjacent side of this angle? Adjacent means next to the angle. The adjacent side is AB, which means it's 12. So the value of tan A is 5 over 12. It's as straightforward as that. 5 is the opposite side. Why do we say it's the opposite side? The side opposite this given angle for this triangle is actually DB, which is 5. The adjacent side, adjacent to this angle, is 12, which is AB. Let's go to sec BDC. Sec BDC. Sec what? BDC. Now, BDC is where? In triangle BDC is in triangle, right angle triangle, BDC. So we say triangle BDC. That's where our focus is going to be. The angle BDC, where is it? BDC is this angle. Now my focus is on this angle for this triangle. What is the definition of sec? What is the definition of sec? Now sec is the inverse of cos. Cos is adjacent over hypotenuse, which means sec is hypotenuse over adjacent. So I know I have hypotenuse over adjacent. What is going to be the hypotenuse side in relation to this angle? Guys, the hypotenuse side is always opposite the 90-degree angle. So the hypotenuse side is 5 for triangle DBC. Then what is the adjacent side of this angle? The side next to the angle, which is DC, that is 3. So we have 5 over 3 as sec BDC. Then the last question, guys, of the day for this live, sine of 90 minus A. We would not have known what 90 minus A is had we not done this first question. Okay. So it's very important to be aware that you can write other angles in terms of other angles. We know what 90 minus A because we found 90 minus A from the first question, angle ADB. So angle ADB is this angle, that is 90 minus A. So you are talking about this angle. So when we say 90 minus A, where are we going? Where are we referring? We are talking about triangle ADB. Triangle ADB. There is 90 minus A. This is your focus. 90 minus A is angle ADB. What do they want? Sine. So you think of SOHCAHTOA. What is sine? Sine is opposite over hypotenuse. So you know it's opposite over hypotenuse. Then you ask yourself, what is the side opposite the angle that you are given, 90 minus A? 90 minus A is opposite AB, which is 12. So the opposite side is 12. Then what is the hypotenuse side of that same triangle? It is 13. 12 over 13. So sine of 90 minus A, guys, is 12 over 13. That brings me to the end of this live lesson, and I hope it was really helpful for those grade 10 learners, standard 8 learners all across the world, grade 10 learners all across the world that are basically preparing for tests. This is basically how we maneuver around an entire full question paper that involves questions like your term 1 aspects, algebraic expressions, your number system, your solving of equations, your exponents, your trigonometry, as basic as you saw it today. Please like the live. Please do share this live lesson when it's uploaded onto my YouTube channel. Please share it with other friends, your families, your relatives, your brothers, your sisters, your cousins, your dogs, your cats, and your American presidents and presidents all across the country. Share it with them so that they can also gain what valuable knowledge you've just received today. Cheers, guys. Have a good day and see you next time when I do see you. Maths is a game. Let's play and get the marks that we deserve.